Problem number 4. A positive, even 4-digit integer consists of only 2 different digits, and the sum of the 4 digits is 9. If this integer is twice another number also satisfying these conditions, what is the integer? Gosh, well, this is one of those problems where it just looks like, where do I even start? Um, it looks hard. But, the best thing to do is just dive in and start kind of working with what you know, and, you know, something might come of it. So, all right, so we know there are two different digits in this 4-digit number, right? So let's call those two digits, let's just call them A and B, okay? So we know that there's either 1A and 3 B's, all right? Because there's got to be 4 digits total, right? So, or we could have 2 A's and 2 B's, or we could have 3 A's and 1 B, okay? And we also know that the sum of the 4 digits is 9, all right? So if we add the 4 digits up, we get 9. And you can see right away that it's impossible to have 2 A's and 2 B's, because whatever we have for A and B in this case, it's going to be even, right? Because you end up with a multiple of 2. You end up with a factor of 2, right? Because this is equal to 2 times A plus B. And obviously 9 is odd, so we can't have this case. So we have to, the number that we're looking for has to have one of one digit and 3 of another digit, okay? So really these two things here are equivalent, all right? Because we don't really know what either of the digits are. So let's work with that. So let's look at some of the possibilities for A and B, okay? So let me just draw a little table here. So let's say that A is 1, okay? Now if we only have one 1, then the other one would have to add up to 8, and 8's not divisible by 3. Okay, so let's just take this case here. But really we'll be able to, these are equivalent, so it doesn't really matter. So if we only have one A, then the B's would have to add up to 8, and 8's not divisible by 3, so that doesn't work. Let's say if A is 2, then the 3 B's would have to add up to 7, and again, that's not divisible by 3. If A is 3, then the B's have to add up to 6, so that means B could be 2. So you could have 1, 3, and 3 2's, and that would add up to 9. And we can keep going through this. 4 doesn't work because the B's would have to add up to 5, right? So 5 doesn't work because the B's would have to add up to 4, and you get 3 of them. That doesn't work. 6, if A is 6, then the B's would have to add up to 3, and so the B could be a 1. And we can keep going. Let's see, 7 won't work, 8 won't work, and then finally 9. If you have 1 9, then you could have 3 zeros, and that would work. So look at that. We've narrowed it down to 3 cases. Okay, we've either got our number either has to have 1 3 and 3 2's, 1 6 and 3 1's, or 1 9 and 3 zeros. Okay? Alright, so, well, let's take a look at those possibilities. Let's take a look at the first one first. Now, we don't know which of the digits is a 3, but there's basically 3 cases, right? We can have 3 2 2 2. We could have 2 3 2 2, or we could have 2 2 3 2. Now we can't put 3 in the last spot because it says that this has to be a positive even number. Okay, so we should probably write out what these conditions are. So it has to be positive, it has to be even, okay, it has to be 4 digits, okay, this is the criteria for the number that we're looking for. It has to be 4 digits, it has to be 2 different digits, and let's see, oh, and the sum of the digits equals 9. Okay, that's just my shorthand way of writing out the criteria, right? And is that everything? I think that's it. It has to be positive, even, 4 digits, consisting of 2 different digits, and the sum of its digits are 9. So we're looking for a number that satisfies that criteria, where half of it also satisfies that criteria, right? Because it's twice another number that satisfies all these criteria. Okay, so these are the criteria. Alright. Okay, so let's take a look at these 3. Now, all of these meet the criteria that they're positive, they're even, they're 4 digits, they're using 2 different digits, and the sum is 9. So let's look at half of each one of these and see if they also meet the criteria. So half of this would be, what? It would be 1611. And that one is not even. So that one doesn't meet the criteria. So we can cross that one out. Let's see, half of this is 1161. And again, that's not even. So it doesn't meet the criteria. This one, half of this one is 1116. Okay, let's see. So that's positive, that's even, that's 4 digits, it has 2 different digits, and the sum is 9. So that seems to meet our criteria. Alright, so that's a good one. And that's all all we can get from the 3 and the 2. Let's take a look at well, we've already looked at the 1611. The only one that will be even is this one, okay? And half of that is what? It's 5. Let's see. 558. Is that what it is? Does that make sense? Okay, I think that's right. And you can see that's not 4 digits, so that's not going to meet the criteria. So our original number can't be this, but it could be this. Okay, so all right, we found one good case, and then the other that really takes care of all the the ones with the 1 and the 6. Okay, and then our only other case is the 9000. Okay, that satisfies all these conditions. But if we take half of it, we get 4500. Now that one uses 3 different digits, so that one doesn't work either. All right, so that's really it. Those are the only cases. So our answer is that the integer that we're looking for is 2232. Okay. Now I like these kind of problems because they look impossible. It doesn't seem like you'd have enough information to solve it. But once you start diving into it and working with what you know and what they give you, and start eliminating possibilities, you eventually get to the answer. So when you are tackling these problems, don't get intimidated. Just dive in and start working. So there you go. The answer is 2232.